pebble of mass 0.05 kg is thrown vertically upwards. Give the direction magnitude of the net force on the pebble during upward, during downward motion, and at the highest point where it's at rest. Did your answer change if the pebble was thrown? Do your answer change if the pebble was thrown at an angle of 45 degree with the horizontal direction? Ignore air resistance. So a very good question. And it's time for us to draw. So we have upward. So when the object is going up, so we have the object, it's going up. So it has a velocity which is more than 0, considering up as positive. Now, what is give the direction and the magnitude of net force. So we need to consider 0.05 kg, and we have acceleration due to gravity 10 meter per second square. Now, what are the forces acting on it? There's only one force acting on it, and that would be, yes, your gravitational pull. Please understand that the object is already thrown. Once it leaves your hand will not continue to push it. I hope you guys have that sense by now. You're in 11th and higher grades. So you have F net is equal to sum of all the forces acting on the object. In this case, it's just one, that is Fg. And this is nothing but 10 J cap Newton. That's the only force acting on it. Oh, sorry, this is, my bad, acceleration times of mass. So many Newton. So basically it is minus 0.5 J cap Newton. Okay, mass into acceleration, and acceleration in this case is 10. That's what I've taken it as. So this answer is minus 0.5 J cap Newton. So I made use of force is equal to mass into acceleration formula. Okay, then what else? Give the direction and magnitude. So direction is downward. And magnitude is 0.5 Newton. Now, during downward motion, what will happen? It's the same funda. See, just because the object is going up and down, the gravity will not stop acting on it, right? So it's the same thing again. So even though it's already gone up, it will continue to be so when it's coming down as well. And what about the intermediate position, that is at the highest point? Even over there, why will the gravity stop? Just because the object is at rest. Even you guys are at rest. Is it not? You guys are sitting, hopefully. Or you might be standing. Let's consider sitting. If I go to standing, then the conversation will be something else. If you're sitting still, even now there are quite a few forces acting on it. But one force that acts for sure is your gravitational pull, right? And there's also something called as normal force that we'll be studying. But gravity is acting on you. Gravity will not care about you guys moving or not moving. It cares about how far you are actually. So that factors we'll be learning in the future. But point is, for this case of when we throw object close to the surface of the earth and all of that, so all of this is true. Okay, so even for case C, just because the object is moving, it will not stop acting. The gravitational pull will not stop acting on it. Right? So that is one thing that you guys have to keep in mind. Now, the velocity is the one which becomes 0 at the peak. The velocity is the one that becomes 0 at the peak. but the acceleration will not change. This we have seen in chapter 1 actually. Let me go back to that. So I meant, sorry, when I tell first chapter, I always mean one-dimensional motion. So we have the acceleration to be minus 10, initial velocity to be to 20. So this would be the case. The object is going forward, and of course, eventually it will come back. So what we are looking at is this. See, just because the velocity became 0 at 2 seconds, can you see that? Velocity is 0 at 2 seconds. Did the acceleration stop? The acceleration continues to be how much? Minus 10. Look at 2 seconds in velocity time graph. The velocity is 0. At 2 seconds in acceleration time graph, what is the value? Yes, minus 10. Okay. And so this has to be, this also has to be the same as A and B. Now, if I happen to throw the object at a different angle, what will change? Right, this is what if scenario. If we happen to throw the object at a different angle, what will change? The velocity component will change, not the force. After it leaves your hand, the velocity component will change, but not the force. The force will continue to be the same. The force will continue to be the same. That is force of gravity. Okay, so here too the answer remains the same. Again, you need to know the reason, not just agree with whatever I am telling, or just tell that, this is the answer. It is because of something. It should not be something anymore. You won't be learning anything in that with that attitude. Understand the reason? Dig into it.